Sequences can be represented with an explicit formula. And sometimes this is called an nth term formula. So the directions ask, find the first 4 terms as well as the 100th term of the sequence whose explicit nth term formula is given. So this formula can be used to generate a pattern, to generate a sequence. And we just need to plug in 1, 2, 3, 4, etc. to generate that sequence. So I want to plug in 1, 2, 3, 4, and then they wanted the 100th term. So I just need to plug those numbers into this formula. So we get 3, 4 times 2 minus 1, we get 7. 4 times 3 minus 1, we get 11. 4 times 4 minus 1, we get 15. And this one you can probably do in your head, but there'll be other ones that you for sure want to use the calculator. 4 times 100 minus 1, we get 399. So I'm just plugging in 1, 2, 3, 4, and 100 into our formula. And these numbers should look kind of familiar because this is actually the formula for question number 1. So if you go back and look at question number 1, this formula actually generates that sequence. So for every sequence, there can be an explicit formula to generate it. Okay, looking at number 8, we have -1 to the n. And the -1 is on the inside of the parentheses. So I want to plug in 1, 2, 3, 4, and 100. So -1 raised to the 1 is -1. -1 raised to the 2 is 1. -1 raised to the 3 is -1. And you can start to see a pattern here. And -1 raised to the 4 is 1. So the even powers are +1, the odd powers are -1, and that's something that we've kind of observed throughout math. So when we raise -1 to the 100th power, that will just be +1. So this sequence is alternating.